Hi everybody. Today we're going to take a look at some gas law problems. You should be copying down all your samples. You should take notes and then complete the sample at the end of this video and bring it to class tomorrow. If at any time you find the presentation is moving too quickly, please pause or rewind this recording to catch up. Taking a look at gas laws graphically, we see in this first picture up on the top where we can speed up the particles by increasing the temperature. We also notice on this diagram here with the two containers with high and low pressure, as you change the pressure, you also change volume. And then graphically, you have here volume versus temperature. As the temperature increases, so does the volume. When talking about combined gas laws, the equation is pressure times volume, and that is divided by the Kelvin temperature. The temperature must be in Kelvin. If you know one set of the conditions, then you can determine the second set. Sometimes you'll see STP in a problem. STP stands for standard temperature and pressure. However, when you see STP, you should think of numbers instead of words. For standard temperature, you should consider 0 Celsius or 273 Kelvin. Since we don't use Celsius in gas laws, only consider STP as 273 Kelvin for gas laws. For pressure, you can use either kilopascals, which is kPa, the value is 101.3 kilopascals, or you can use 1 atmosphere, which is ATM. Either pressure unit is okay as long as both pressure units are the same. The sample problem. A gas with a volume of 250 milliliters at 35 degrees Celsius and 100.3 kPa is heated to 57 degrees Celsius and the pressure is increased to 151.3 kilopascals. What is the new volume of this gas? Make sure you copy this down so that you can follow along. You need to find the equation if you don't know it. It is on your reference table on Table T on the back page. It says combined gas law. It has the equation for you, and it also indicates what each letter represent. So you have P1, V1 divided by T1. Then you have a second set of conditions, P2, V2 divided by T2. Step 1 is always to write the equation. So P1, V1 over T1 equals P2, V2 over T2. Step 2 is to have your given values. There are more values to write down, so you really should keep track of all of your givens. Your P1 was 100.3 kPa. Your V1, your first volume, was 250 milliliters. Now your first temperature was 35 degrees Celsius. However, we can't use Celsius in gas law problems. Therefore, you had to convert it to 308 by adding the 273 value. That's right there. We use also Table T to get that conversion. You must change to Kelvin for gas laws. Now we have a second set of conditions. We have P2, which is 151.3 kPa. The second volume is what we're trying to find. And then lastly, we have a second temperature. Again, that temperature was 57 degrees Celsius. We want to convert that to Kelvin. That's why 273 is added. And that new temperature is now 330 Kelvin. The next step is going to be our substitution. We substitute in all the numbers and the units. Now we're going to solve for V2. Therefore, we have to get V2 alone. Here's how we start it. We want to get rid of the 330 Kelvin. So we multiply both sides by 330. The 330s cancel along with the unit Kelvin. Kelvins cancel on the other side. Now we want to get rid of this next value, which is the pressure value. Since they're multiplying V2 times 151.3 kPa, we're going to divide both sides by 151.3 kPa. And this is how you do it. Dividing both sides by 151.3 kPa. The kPa on this side here is going to divide out on your left. So now you're left with 330 times 101.3 times 250 milliliters divided by 151.3 times 308. The only unit left is milliliters, which is what you should expect since volume is the unit is milliliters. So all the numbers are together. Solving, we get 179 milliliters for V2. You should try this also on your calculator. Make sure that you get the same answer. Here's the next sample problem that you need to write down and then bring the answer to class. So, sample 2 is 4 milliliter sample of gas, has a pressure of 1.5 atm, which is our pressure unit, at 20 degrees Celsius, which has been heated to 35 degrees Celsius, and now has a volume of 5 milliliters. What is the new pressure? Okay, so this is what you need to do. Using sample problem 2, write down the equation to be used, write down your given information, substitute the values for the variables in the equation, solve for P2, and then you bring your work and your final answer to class tomorrow. Okay, see you then. Bye.